Okay, hello guys. Today we'll be talking about convex and concave. Firstly, we will be looking at the mirrors. A concave mirror will have a spherical shape inwards the mirror, and convex there will be a spherical shape going outwards the mirror. Okay. So firstly, we need to talk about the focal length and the center. So C is the center and then F is the focal length. So what is the relationship between these two? So basically C is just the 2 times of the focal length. Okay, this is very important. You need to remember. Okay. And then after that, we'll be looking into a concave mirror first. So how does the light shines through the mirror? Okay, so this is very important. This is the main principle or principle of how the mirror works. Okay, so firstly the lights will go through the mirror, and then after that it will reflect towards the focal length right here. Okay, so this is the first step. Okay, the second step is that the light will go through the focal length. Let me adjust it. Okay, and then after it hits the mirror, and then after that it will bounce back in a straight line. Sorry, this is the first time of me working with iPad, so I'm a bit, not familiar. And then after that, you will do one more line from the object through the center and reaches the mirror, and it's basically doesn't reflect because it just goes to the mirror and then it will reflect back to the center point to the object. So basically it does nothing right here. So basically now you need to mainly focus on basically these two. So let me erase the center point. It's just a concept so that you will know. So basically now you will be looking at the intersection, and then this will be where the image lies. Okay, and then let's move towards the convex. I will discuss further on later where the object stands in different position from the mirror. Okay, so the convex, the same thing applies here. The object has a light shine through the mirror, and then after that for convex is a bit different. Since the shape is a bit the spherical shape is pointing outwards, so the light actually goes through the mirror and then hits the focal length again. Okay, and then after that, this will be the first step, and the second step is the same thing, where the focal length it will be hitting the focal length. Okay, so as you can see, for now you can't find the intersection point. The intersection point will basically be in the focal length, which is basically non-existent. That's why you need the third principle, where the third point where the object shines to the center point. And now you can see there's a tiny little intersection in front of the focal length there. I'll just erase the line where it goes through the focal point, and now you can just look at it. There's an object right in front here, or in front of the focal length. It's just a tiny little object. Okay, so now we would discuss about, hey, why there is the images are shining. One is upwards and one is inverted or downwards basically. So okay, just don't ask. It's just all virtual image. So all the images that are upright are virtual, and all of the images that are inverted or pointing downwards are real. Okay. Yeah, so this is the main principle of it. Okay, so now we will be looking at the position of the object in front of the mirror. So firstly, we could just say that the object it's just standing right in front of the mirror. Okay, so let's just put the object here. Okay, so the same principle applies. Firstly, you draw the line to the mirror, and then it reflects back to the focal point. Okay, focal length, and then after that you draw the same thing. Secondly, you draw, it passes through the focal length, and then after that bounces back in a straight line where it intersects here. Okay, so this part we will call it that this object is the image is real, inverted, and diminished because it is smaller compared to the object. Okay, so basically any objects that is in front, or basically it's here, behind or in front the center, the image will most likely lies in between the focal point and the center. Okay, so let's go back, and then now let's make the object on the center. Okay, on the center. So now let's see how does it do. So it goes to the mirror, it goes down, and then after that it will goes through the focal point, then after that it will reflect here. Oh shit, there must be some error, because normally it should intersect right at the center. Yeah, maybe just give me a second here. Maybe I didn't draw precisely enough. So it goes here, goes through here. Okay, in the meantime, I will tell why that I don't really draw it from the object to the center point, because that from concave it doesn't really affect much. It will just the mirror will just reflects the light back to the center point, and it does nothing. Okay, that's almost it. Yeah, so the same thing, it's real, inverted, and same size. Okay, yeah, so normally when your object is on the center point, it would normally reflect back at the same point also. So basically at the center point with the same size. Yeah, so basically that's like your the best distance for you to see how high are you, something. Okay, and then now let's go to the third scenario. Where the object lies in between the focal point and the center. So same principle. Firstly to here, secondly it reflects back to the point. Come on, I don't want 45 degrees Celsius. It's okay, I guess. And then after that it goes through the point, and then after that back out. Okay, now it's yeah, I mean, like, for now it should be magnified when you are in between the focal point and the what. Let me just retry it again. Probably my drawing, this really needs precise drawing, not gonna lie. Okay, let's draw it down here, down here. Okay, now probably you could see a little bit better that it is behind the center point, so in front, the image. So now the image is still real because it's inverted, but it is magnified. Okay. So now we will move on to the fourth scenario. Yeah. Which is that the object is on top of the focal point. Okay. Same thing goes here. It goes to the focal point, the lens, and the lens will go to the focal point. I'm pretty sure that's not very good. Yeah, this is much better. Nope. That, okay. And then after that, now, as you can see, how can I draw the light goes to from the object to the focal point? It's not directly down. Okay, so basically you can't apply that law here. You only can apply the third law, which is not the third law, the third the third principle, I guess, or something, that the light goes through the center point. So here now, like, it's parallel basically. How are you going to draw the image? Where is the image? Well, it doesn't form an image. That's your answer. It's basically, it goes to infinite. The light just goes through. You can't see the image at all. So yeah, probably you could say this is the blind spot of the mirror, where you stand, you can't see yourself in the mirror anymore. Okay, and then let's go to the fifth. The fifth will be right in front of the focal point. Okay, so this is the same thing. Okay, the first principle, the light goes through the mirror, and then after that it reflects back, and then after that, now, yes, obviously you can reach to the focal point, but if you reach to the focal point, it doesn't touch the lens anymore, so it's irrelevant. So you use the third law again, the same thing, where it goes through the center point, and then now I want you to see that this, sorry, I forgot to draw this thing. It should be a dotted line, you know, it's like a dotted line where it intersects somewhere here. Okay, so now you can see your image is upright. Okay, so now this, as the image is upright, so according to the principle, it's virtual because it's upright, and then it is magnified. okay, because it's bigger than the object itself. Okay, so yeah, that's basically all the 5 position where the object lies. That where the object lies. Okay. And then now let's move to the. Yeah, I actually can leave it there. Okay, it's fine. Let's move to the convex. So convex. Okay. So yeah. Here actually, yeah, I could also put that, you know, that this will be the focal line, this is the center, and that is the image. Okay, yeah, you can see it's the same thing. So here you also can just put the same thing here, but it doesn't really matter. It's not gonna lie. Yeah. Okay. I just edited out the this part because I did some mistake, and I think that it's too time consuming. And also I just realized that landscape probably will be better, much better. Okay, so same rules applies here. It goes to the lens, from the lens it goes to the focal point. Okay, and it also reflects back, okay, because it's a mirror. And next thing you want to do the same thing also. It goes to the focal point, and then it also reflects back. Okay, then since there is no intersection here, the intersection lies same principle, you know, so you use the third principle, the third rule, that it goes through the center point, and now you can find your intersection, yeah, you know, without this without it touching the focal line. Yeah, it's the same thing. So it's upright. So upright is what? Virtual. Okay, and then after that is diminished because it's smaller. Okay, so yeah, done. So this is the first position. Okay, second position. Again, at the center point, you know, does the same thing. Goes to the lens, goes to there, it flows back throughout. Oops, too fast. Okay, and then after that, same thing. Now you don't need to do this. You don't need to apply the second law, since you already saw what the second law does. Does basically nothing, just like you. Sorry. Okay, and then after that it goes back the same place. Okay, the same thing again. Upright, virtual, you know, blah blah blah. Okay. Yeah, we can go to the next one, the next position. And then as you can see, slowly, I mean, like, if you are good in recognizing the pattern, it basically doing the same thing. It just goes to the center, goes to the focal point. Okay. Oops. And then after that, it goes to the center, and it produces the same result. Upright, virtual, and sorry for my bad handwriting. Okay, and diminish. Okay, so we can here safely assume that convex, no matter where the position of the object lies, it is always upright, virtual, and diminish. Okay, yeah, it's simple. That's about it. Then now we would proceed to the lens. Okay, so now before we go to lens, I just want to say that the summary of the concave vs convex mirror will be at the end of the video. So firstly, we will move on to lens. Okay, for lens, the same thing occur, same shape, same name. concave is the eaten apple, okay, it's like an eaten apple, and convex will be a compressed ball, okay, kind of like that. Okay, so firstly, okay, the principle of lens is a bit different now. Before that it has two, it has three for mirror. Now it has two only. It's very easy. So firstly, you will go to the lens, go through the lens to the axis, okay, and then after that, the same law applies. Okay, so the first one, you will go to the focal length, okay, and the light passes throughout, okay, here, okay, and then after that, the second law is that it just goes through the center, so basically at 0 axis, okay, and then you will look, and then you will find a image down very here. Yeah. Okay. So this is the basic rule of the concave lens. Okay. Same thing goes to the convex lens. Goes through the lens, go to the focal point. Come on. Okay, goes through, and then after that goes to the middle. And then you can find your intersection right here. Okay, yeah, so that's about it. Only two principle, okay, two. So same things here, okay. I will just straight away skip the first position of the concave lens. We will go back to the concave lens. First position, object is right in front of the center or behind the center here, okay. So the object will, the image will form in front of the lens. It's virtual because it's upright, okay, and it's diminished because it's smaller than the object, okay. And then after that, yeah, let me just erase everything here, and then we will move on to the second position, which is on top. So same thing, object goes through the lens, bounce at the focal point, and then after that it goes through the middle. So two laws apply, very simple, very straightforward, okay. It will form here, same thing. So upright, and because it's upright it's virtual, and then because and then it's diminished, okay. Yeah, don't need to explain too much here, okay. It's very simple, okay. And then goes up from here, and the result should be the same. Goes to the lens, goes through the focal point, goes through the middle, okay. Second law, goes through the middle, form the same thing. Oops, again, same thing. So again, upright, because it's upright it's virtual, and then it's diminished, okay. Yep. Okay, now you can move on to the convex. Okay, so the convex, same thing, position, it's in front of the, yeah, I can draw it again, you know, here, 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 you know, I don't really need to explain why, I already explained it already. So same thing, when object is in front of the center, you know, 2F, it will produce inverted, and because it's inverted, so it's real, and it's because it's real, No, not because it's real. So, and then it's because it's smaller than the object, so it's diminished. Okay. Yeah, I don't know how to spell. Okay, don't mind me. I'm not studying English degree right now. Okay. Not taking the English degree right now. Yeah, my broken language. Yeah. Okay. And then after that, so what happens when the object is on the center? This is the second position. Same rules apply. Goes to the lens bounces to the focal point. Okay. Yeah, actually it doesn't bounce back. Okay. Let me just erase here. Yes, this is too big. Yeah, you get my point. Okay. And then after that goes to the middle. Oops, I think I didn't draw enough. Forgive me. Okay, forgive me of my bad. Yeah, it's around here. Look at it. It's right on top of the 2F. Same as the image. Same as the mirror. So the image, real, inverted, and this time will be the same size. Okay. Yep. Okay. Moving on to the third position. Right between, oops, should have used the white pen. Okay, right between the focal length and the center 2F. Okay, same thing. To here, goes here. I really need to draw a longer line. Seriously need to draw some longer line. Okay, oops, yeah. That's what I'm saying. Need to draw a longer line. Man, okay. Yeah. I really respect, those tutor which are on YouTube. For example, the organic chemistry tutor. I don't know what app they are using, but them, yeah. And then as you can see, it's the image. It's also same. However, it's this time it's magnified. Same as the mirror, but in the mirror it's concave, in the lens it's convex. Okay, everyone get their shares of usefulness. Okay, so this is the first one was in front of 2F. Second one is on 2F. Third one is in the middle of 2F, and then now the second last position, which is the fourth position, is on top of the focal length. Okay, so what will happen? So same thing goes to there, to the mirror, to the lens, and then after that it has its I think I draw too long. Yeah, just on the lens. Okay, and then after that, same thing. Look at this, beautiful. Okay, it's parallel again, so it is infinity and no image are formed. Okay, it's actually pretty simple, Okay, so take a guess. What happened when the image is in front of the focal length? It will be the same thing, okay, as the mirror. Okay, applying those two laws again, goes to the lens, reflect to the focal point. This time draw a long line, and then after that in to the middle. Oh shit, sorry. So this time it's actually no longer at the other side, it's actually outside, so which means it's here. Damn, look at it. So now it's virtual because it's upright and it is magnified. So yeah, that's basically it. Very simple, right? Okay, now let's move to the calculation. Okay, so the calculation for mirror, there's not much about it, only for the lens. Okay, the lens, you can determine the object distance, image distance, and the focal length through this formula. Okay, and f is obviously the focal length. Okay, everything is in meter, yeah. Okay, so u will be the object distance, v it's the image, the distance of the image, meter. Okay, yeah, with this formula you can find any of these three if you have two of them. Yeah, I mean, like, you guys definitely do math, so yeah. Okay, so now let's move on to the summary of the concave and convex mirror. So the differences are, first of all, the type of concave and convex mirror. Concave is a converging mirror, while convex is a diverging mirror. An image of a concave can be virtual or real, while the convex can only be virtual. The focal length of a concave mirror is always positive, and the convex mirror is negative, as you can see here. Positive and negative. And the uses of an example for a concave mirror is to magnify images. Okay, one of an example, it can be used as a shaving mirror. I hope you guys can see shaving mirror. Okay, and for convex, it is used to cover a large area. So for example of it, it can be used in a car rear or side mirror. Okay, now let's move on to the lens. Okay, for lenses, a concave lens and a convex lens is basically the opposite of the mirror. So just now, for concave mirror, it is converging, so now it's diverging. And convex mirror is now converging. Oops. The image form is also the opposite. So concave just now was virtual or real. Now it's only virtual. And convex will be virtual or real. And the focal length will remain the same, as you can see. It's still positive here, it's still negative here. Okay, so positive here and negative here. Okay, the uses of an example for a concave lens is to correct nearsightedness. Okay, so it can be used as eyeglasses. Okay, besides that, it also can be used as camera lens and so on. While for convex lens, it is used to again, magnify object. So it can be used in magnifying glasses. Come on. Okay. Magnifying glasses. Okay, I hope you can read it. Cameras. Basically, both of them are used simultaneously. So one, it can due to the property of diverging and converging. Camera, when it zoom in, you use convex lens so that it can magnify the object, and concave lens when you are zooming out. That's basically it. Okay, I hope you guys enjoy the video. I'm sorry I couldn't make it a perfect video due to my upcoming exams. I just want to do a quick one so that it could be beneficial to you guys maybe, but it definitely will be beneficial for the future me when I'm looking back at my notes. Anyway, thanks you guys, and see you next time. Bye.